Imagine you're going 100 kilometers per hour, and suddenly your wheels turn into solid rock. Your spine would collapse in less than a minute. Just 150 years ago, human movement was nothing but agony. There's a reason the bicycle was nicknamed the bone shaker. One invention saved us from this agony, providing freedom of smooth movement. Today, we uncover this dark revolution. It is a tire. History wasn't changed by a grand engineer. In 1888, Irish vet John Boyd Dunlop saw his son suffering headaches from hard wheels. He wrapped a garden hose around the wheel and filled it with air. The result was astonishing. Air absorbed the shock, making the bike ride like a magic carpet, smoother and faster. This was the birth of the pneumatic tire that supports modern civilization. People mocked it, calling it a suicide ride on a cushion of air. But the true revolution that changed the roadscape appeared in France. In 1895, the Michelin brothers entered a race with pneumatic tires, suffering 22 punctures. Spectators mocked them as raggedy rubber. The initial bibendum best shows this bizarre period. His eerie look reflected the brothers' fanatical obsession with tires. They meticulously stacked various tires to form the shape of a man, resulting in a grotesque rubber golem that appeared to be miraculously alive. But their obsession wasn't in vain. They painstakingly fixed every single puncture, ultimately gaining widespread attention for the astonishing speed of their tire replacement. This led them to develop the world's first detachable tire technology. They also created the Michelin Guide to get people driving and consuming tires. Their monstrous obsession opened the driving era we enjoy today. Michelin, Bridgestone, and Goodyear spearheaded this colossal tire revolution. But in this fiercely competitive war, who annually produces the single largest number of tires? Surprisingly, it's the toy company Lego. They make over 318 million mini tires every year, surpassing giants like Michelin. They broke the Guinness World Record in 2012. Since 1958, Lego bricks have been the wheels for children's imagination.
Wow, look at all the bricks.
Though these miniature tires don't hit the actual road, they are undoubtedly our first tires. Now, let's put down the toys and enter the world of real scale. We flew to Vietnam to unlock the tire's secrets. This is Binh Duong, the heart of Vietnam's southern industry. Can you see that massive fortress filling the horizon? It's the Cum Ho Tire production base, covering 315,000 square meters. The factory is so vast that staff use motorbikes to move around. Walking might take your entire lunch break. Here, 2,000 employees produce tires 24/7 without stopping. With an annual output of 12.5 million units, this is a key export base for North America, the Middle East, and Asia. This is a high security zone, usually off limits. But today, our team secured exclusive access. We will now reveal the entire process of how rubber sap transforms into advanced high-tech wheels right here in Vietnam. Follow me. The journey begins here, in the raw material warehouse. This isn't just a warehouse, it's a spice pantry determining the tire's flavor. Here, nature's gifts meet cutting-edge science. Top-grade Vietnamese natural rubber, high-performance synthetic rubber from Korea and Europe. The best materials, including special ones flown in from across the globe, are gathered here solely to create the perfect tire. But wait, if you look closely at these ingredients, there's something strange about them. We know tires are pitch black, but these rubber blocks, the main ingredients, are not black. So, what is the natural color of rubber? It's actually yellowish or white. In fact, 100 years ago, early tires were indeed white. But white tires were weak like erasers and vulnerable to heat. So, they added a magic powder, carbon black. When this soot-like carbon bonds with rubber, strength increases tenfold. That is why tires are black. To ensure the exact quality and precision of the final recipe, every single ingredient is tracked and meticulously verified in real time before entering the giant mixer. The mixing ratio is a secret, as guarded as the Coca-Cola recipe. This ratio defines the tire's character. Michelin adds silica for fuel efficiency and longevity. Pirelli adds more carbon black for extreme grip, even if it wears down faster. Some use unique ingredients. Yokohama Tire uses orange peel oil to soften the rubber. It's amazing how a tiny difference protects a manufacturer's pride. Inside the mixer, friction heat exceeds 100 degrees. The master batch is born, hot like fresh bread. But fresh rubber is too hot, soft, and weak. It can't be used yet. So it passes through a cooling line, resembling a long laundry rack, as the sheet rides up and down in cool air. The flabby dough hardens into the desired shape. The cooled rubber sheets are folded neatly to prevent sticking and move quietly to the next step. Here, the sheets wait to become the hard outer skin or the air-holding inner skin. First, let's make the tread, the outermost skin. We will extrude the rubber sheet into specific shapes. Like squeezing striped toothpaste. Various rubbers are tangled inside the machine. But don't worry. Passing through the nozzle, they settle into calculated positions and extrude as a single sheet. Emerging rubber hits 120 degrees due to immense pressure. It's more like sticky gum than a hard sheet. So we move it quickly using long rollers. For the next process, a worker attaches red ink equipment. What are those colorful lines on the rubber? They aren't defects. It's a rubber barcode to prevent mixing thousands of tire types. This special ink must be compatible, with the vulcanization process reacting chemically without weakening durability. But this beautiful work isn't finished. To lock these colors into the rubber forever, we need a cold touch. The marked sheets pass through the cooling line again. This stabilizes the rubber's physical properties. It's like reverse pottery firing. Pottery hardens in fire. The rubber instead finds its strong and lasting form in the cold air. Cleaned and cooled rubber passes through an air blower, drying completely. Any remaining moisture is fatal to tire quality. Dry rubber is still sticky like a sticker, so we roll them up like a parchment scroll to prevent sticking. It rests on the shelf for aging. Now, the tread is ready. Next is the tire's spine, the carcass. This sheet is fabric cord made of nylon or polyester. These are high-strength synthetic fibers. We roll the fabric cord with rubber sheets. Rubber permeates the fabric, giving structural stiffness and durability. This fundamental carcass serves as the skeleton, effectively withstanding internal air pressure and all load shocks. Like the tread, the carcass is wrapped in cloth for storage. Rubber sheets now head to the cutter. They are sliced to the exact length of one tire, at precise angles. Precision within 1 millimeter is required. Though laser cutting is often considered the best, the cutting surface burns instantly, so the rubber here is cut using a special alloy knife honed to the utmost sharpness. Meanwhile, the most crucial part of the bead is being made. This bundle of steel wire is stronger than piano strings. It uses special steel cords with far greater tensile strength than ordinary wire. Did you know rubber goes into the bead too? Bead coating rubber prevents corrosion and bonds the wire to other rubber layers. Crucially hidden where the tire meets the wheel rim, the bead grips extremely tight to effectively prevent the tire from slipping. Why did we start putting metal inside tires? In the 1890s, early pneumatic tires would strip off the rim on corners. Rubber alone couldn't grip the steel wheel. So engineers had a brilliant idea. Put steel inside rubber.
Perhaps a steel wire woven into the bead.
Planting steel loops at the edge created the bead, the core of modern tire safety. Now, with all materials ready, it's time for assembly. First, we build the outer skin. A rotating drum winds the belt plies. Next, it winds the cap plies. This suppresses centrifugal force and holds the belt layer tight, maintaining the tread shape. Finally, the tread rubber layer goes on top. This is the frontline armor that meets the road. The finished outer skin is mounted on the forming machine. Simultaneously, another drum builds the inner skin. We wind the inner liner. A thin, strong membrane acting as a tube. The inner liner prevents air from leaking out. Then comes the critical moment. The powerful steel ring, the bead, seats accurately on both sides. Now, the magic happens. Air is injected, and the flat cylinder instantly transforms into a donut shape. The inflated inner skin meets the waiting outer skin. Rollers rub the sheets intensely to remove air and physically bond the parts. Uncured rubber is sticky, so just overlapping them creates a solid temporary bond. This newborn tire is called a green tire. Workers visually scan and touch every inch to check for tears or debris. Now, a hot stage awaits to be reborn as steel-like tires. It's time to cook the green tire. We place it into a giant steamer called a curing press. It's like baking a giant waffle. The tire is positioned perfectly in the center. 180 degrees heat, 30 atmospheres of pressure. This immense energy transforms the floppy dough into a resilient, tough tire. The mold walls carve the complex tread patterns we know. Here, the vulcanization reaction, discovered by Charles Goodyear in 1839, occurs. How did the father of rubber discover this? Actually, Goodyear was more madman than inventor. Obsessed with rubber, he sold everything: furniture, clothes, even toys, to buy more rubber. He went to jail for debt and nearly starved, but never stopped experimenting. People mocked him. If you see a man in a rubber coat with an empty wallet, that man is surely Charles Goodyear. But one cold winter day, he accidentally dropped sulfur-mixed rubber onto a hot stove. History flipped in that moment. Instead of melting, the rubber became tough like leather. Goodyear shouted, "Eureka!" Thanks to his great mistake, humanity escaped the curse of rubber that melted in summer and cracked in winter. Beyond tires, this includes your shoe soles, hospital surgical gloves, and the window sealing that blocks air inside airplanes. All elastic things were born on that hot stove, fueled by Goodyear's tears and sweat. Sulfur binds rubber molecules, creating elasticity. The freshly baked tire is hot and covered in worm-like rubber hairs. These aren't whiskers. They are vents where trapped air escaped, pushing rubber out. Like pasta noodles squeezing out of a machine. Having survived the heat, the tire moves to inspection. The final inspection process is much like a thorough health checkup. Simply looking fine on the outside certainly doesn't guarantee the product is truly healthy. First, we thoroughly apply lubricant to the bead section to fully protect it from the precise, high-contact inspection machine. The protected tire enters a high-speed rotation test. Spinning furiously, we analyze vibration to find invisible defects. Ever seen red or yellow dots on a tire? Since tires aren't perfect circles, weight varies slightly. The dots mark the heaviest or lightest points to help balance with the wheel. After balancing, tires head to the final check. Even after machine tests, they cannot escape the expert's eye. Eyes trained by thousands of tires a day spot 0.1 millimeter specks. Hands detect internal bubbles that machines miss. The factory's most expensive asset isn't robots, but the experience of these engineers. Only those who pass every test gather at the shipping dock. Born in heat and noise, they finally rest here. But this silence is the calm before the storm. Soon, they are destined to race wildly on hot asphalt. These tires will now be loaded into containers for global shipment, including to North America, Europe, and the Middle East. Not just as rubber chunks, but as reliable feet ensuring someone's safe return home. This is the birth story of the tires on your car. Just as wood wheels evolved into rubber 100 years ago, tires face another giant shift. What does the future look like? You might think of airless tires. Sorry, but that's old news. They shattered the stereotype that tires must be round, creating the sphere-shaped tire. Surprisingly, this tire has no axle. Like a maglev train, the car floats on the wheels using magnetic levitation. This allows 360-degree rotation without turning a steering wheel. It can move sideways to conquer narrow parking spots. While the body evolves, the tire's brain is awakening. Implanted microsensors analyze more than just pressure. They track wear, temperature, and even black ice in real time. This data communicates directly with autonomous driving systems. The tire becomes the car's sensory organ. Are you worried about the complexity? Don't worry. The smartest engineers on the planet are working day and night on your behalf, right now. We just need to enjoy the finished future. Started from a garden hose 100 years ago, This black revolution has reached the level of AI. Tire evolution is human civilization's evolution. As long as wheels turn, our challenge will continue forever. If you enjoyed this journey, please like and subscribe. Thank you for watching.